Thanks a lot. I appreciate that. That was good. Dylan, today we're going to be talking about analyzing graphs of functions and relations. Okay, something you're going to want to make sure that you see on all of our assignments. Check this out right here. This is new vocabulary. All right. Now, you guys know what the difference between zeros of a function and roots of a function are?
They mean the exact same thing.
That's true. They do mean the exact same thing. The words that mean the exact same thing. Bailey, do you know what those actually mean?
It's where the graph crosses the x-axis.
That's right. It's where the graph crosses the x-axis. Now, if we were to look at this graph, does this graph have any zeros or roots in this graph?
No.
No, it doesn't, because it doesn't cross or touch the x-axis. All right? So this one does not. Now, if we wanted to, remember, we have line symmetry, point symmetry, even, and odd function. And by the way, what you should have in your journal already, I'm going to zoom out real quick and take a screenshot of this. This should be in your journal already, okay? These graphs right here have what's called line symmetry. Can everybody clearly see that the line that splits this graph is through the x-axis? And this graph is split perfectly symmetrically through the y-axis. So what type of symmetry are the first two graphs in your journal? That's line symmetry. Okay. Now, the next one that you're going to be talking about is what's called point symmetry. Okay. Right here. It says the graph of a relation is symmetric with respect to the origin. And by the way, the origin is known as a point right here. If and only if, for every point x, y on the graph, there is a point negative x, negative y, also on the graph. So take your graphing calculators, turn them on real quick if you would. All right, turn on your graphing calculator. If you would, please hit x to the power of 3. X to the power of 3. And I want you to hit zoom 4. Okay. After you hit zoom 4, what I'd like you to do is hit second zoom. Hit the second and the zoom button. And if you would, please, with your graphing calculators, turn the grid line on. Turn the grid line on. That'll allow us to be able to investigate the graph a little bit easier. So you'll see on this graph, if you turn the grid line on, we have 0, 0, we have a 1, and a 1, we have a negative 1 and a 1. So if you guys were to look at a table, if you have 1, 1, and negative 1, negative 1, that follows the principle of any xy on a graph would have a what? Would have a negative x, negative y. What type of symmetry is this? This is called point symmetry. So check out your table here. It's second graph. Let's look at your table. You have negative 4, negative 64, and you have what? 464. Negative 3, negative 27, 327. All the way up. Every single point that has an xy coordinate has also what? If you have an x and a y in this graph, what else do you have? You also have a negative x and a negative y. That's the definition of point symmetry. Okay? Right here. For every x, y on the graph, there's also going to be a negative x, negative y. So you're going to be asked to find what type of symmetry your graph is. Okay? Line symmetry, pretty easy to see. Point symmetry, you're going to have to look at your graph and you're going to have to test it. Okay? So what are we going to do first? The very first thing I want us to do is I want us to analyze our very first graph right here. You were asked to look at the graph and evaluate it at 3 places. First place, at negative 2.5. The next place you were asked to evaluate it is at a 1. And the last place was where x was equal to 7. So right now, these are all of the x values. So what I'd like you to do, on your graph right here, I would like you to plot negative 2.5 as an x, a 1 as the x, and 7 as the x. Now the next thing we're going to analyze this graph where the x value is negative 2.5. So what I want you to do, with your pencil, go up from negative 2.5. Just go up all the way until you touch the graph. All right? And then from where you touch the graph, go over to your y value. Okay? So right here, what's my x value right there? My x value is negative 2.5. What's my y value that corresponds with it according to this graph? 12. Okay. If we evaluate a 1, I want you to do the same thing. Go over to where the 1 is on the x-axis. Go up. Touch the graph. So right here, this point right here is at a 1 for your x value. Then go from there over to your y value, which is your y-intercept. Where does that look like it's going to be located? Very good. Now, we're not using this function right here. We're not doing it algebraically. We're just doing it graphically. Okay, so if it tells you to analyze a graph, analyze the graph. If it tells you to do it algebraically, then we're going to use the equation. And last but not least, we're going to use the 7. We're going to go all the way up from the 7. And from right here at this point, we're going to go all the way over here. And where does that look like it's going to be according to the graph? Okay. Looks like it's going to be at an 8 according to the graph. But now we're going to look at this function algebraically. We're going to see if all of the numbers that we kind of use graphically end up matching the algebra. Okay? So right now, I want you guys to turn your graphing calculators on. We're going to go over some keystrokes. So turn them on, hit y equals. Clear this out. We're going to type in a 2. And to get the absolute value bars that are on our graph, I want you guys to hit alpha and then the window button. Okay, take a look at that. To get right here, the keystrokes that you're going to want to put into your journal are this. Hit the alpha button, and then hit the window button. That's a shortcut to get to the ABS, which does not represent anti-lock braking system. It represents, that's absolute value, so it's the alpha window and then the number 1. So you press enter, and now you have your absolute value bars. Inside of it, what was our equation? Was it x minus 3? Was that right? Okay, and then outside of the absolute value bars, put plus 1. You get graph. Now I'm going to hit zoom 5. Not that one. So, zoom standard. Here we go. Zoom standard. There's our zoom standard. Let's zoom square. So it looks like. There we go. So there's our absolute value graph right there. If we check our table, there we go. If we check our table, when it's a 7, where is it actually at? It's actually at a 9, algebraically. Over here is the 1 still at a 5. Okay? And would you guys agree? Negative 2.5 is going to be where? Right between a what? Yeah, what number is exactly 12? So you could say, hey, you know what? A negative 2.5 is perfectly between a negative 3 and a negative 2. Just like 12 is perfectly between an 11 and a 13. What if I wanted to check the negative 2.5 on the table? What are the keystrokes to be able to do that quickly? How can I check negative 2.5? tell me where do you go? What I would do is hit second window and start the table at negative 2.5. This is your table setup. So you can start your table exactly where you want it to start. Okay, so then if I do it, I can check my table. And now, at negative 2.5, I am actually at a 12. All right, guys, the next two problems we're going to talk about are problem number 2 and 3, and I want us to focus on writing things in interval notation. Okay? So what I'd like everybody to do is get a couple of colors, all right, for your twistables or highlighters. We're going to do 2 different colors. One of them is going to be in blue. I'm going to do my domain in blue, and I'm going to do my range in green. Okay, so we're going to go ahead and do that. All right, what I'd like you to do right now is right here on the x-axis, I'm going to make this nice and thick. I want you to draw an arrow going all the way from side to side in blue. And this right here, we're actually going to start here and work our way up. All right, so you'll see that the graph right over here, this, if you read it left to right, this is where the graph starts, and it's going all the way across, and it's continuing to go across. So the domain starts here, and then we have this arrow right here. Does that arrow have an ending point?
No.
It does not. So if that arrow is going to the right forever, then over here, looks like that's going where? That's going to positive infinity. Where does this actually start? This is not going forever to negative infinity. It starts right here at a what?
Negative 5.
Negative. So right here, put negative 5. Right here, going from negative 5 all the way to positive infinity. And this is your what? This is your domain. Okay? Now, look at your range. Where does it bottom out? It actually bottoms out right here. Where does that bottom out? So put negative 2. And this graph is going up, up. It looks like it stops here, but it's not really, because why? That arrow is going up. So way up here, what am I going to put? Positive infinity. Very good. And this, everybody, this is what's called your range. Your range is dealing with your y values, right? That's your, I'm going to put in parentheses, that's your y values, just like your domain is dealing with the set of your x values. So we're going to write our answer not in set builder notation, we're going to write it in interval notation. So if it starts right here at a negative 5, our ordered pair is at a negative 5, 2, but if the x value is at a negative 5, you're going to use what's called a hard bracket. Okay? The hard bracket means equal to, so we're starting at a negative 5. And where am I traveling to? I'm going all the way across to positive. And we, yes, Raymond, what do we have to use? We have to use a, we can never actually reach. Okay? We're not going to touch infinity. You might write it in a poem, but it's not going to work in reality. Now let's check this out. This is our answer in interval notation for domain. Now look at our range. Where does our range start? What's the smallest number you can find? Negative 2, right here. So it bottoms out. Is that going to be a soft or a hard bracket? Hard. So we're starting at a negative 2. And where is it going? Is it going up or down? Going up. So we're going to say it's going towards. And what kind of bracket? That's right. A nice soft bracket. That is your domain and your range for problem number 2. Okay? What I'd like you to do for a brief few moments, see if you can set up number 3, do as much as you can. Okay? See if you can figure out the domain and the range for problem number 3. This is a little bit trickier. We're going to cover it in just a second. All right. In graph number 3, we can see that this arrow is going forever and ever towards negative infinity. So it's going forever to negative infinity, but then it stops right there. So what I want you to do, I want you to put negative infinity right there, and then it goes all the way over to the number 7. Now, as we go, this is going forever to the left, so that's negative infinity. As I travel down this graph, you can see that right here, where x is the number 4, that's not plotted here, but it is plotted right here. And 5 is plotted, and 6, and 7. So technically, the domain starts going towards negative infinity, and it travels all the way to the number 7, and it includes the number 7, so that's why we do what's called a hard bracket for number 7. Soft bracket, hard bracket. All right, now the range is a little bit more difficult. What I'm going to do right now is I'm going to draw an arrow starting from the bottom going to the top. Okay? Now, would you guys agree that this graph is definitely not going down forever? Okay, so right now I'm going to use my eraser. I'm going to say it looks like it starts right about there, but I've got a problem. There's a what? There's a gap right there. So I'm going to, boom, let me gap it. Oops. That's okay. Check it out. Where is the range right here?
1, negative 1.
Yeah, right here it's at a negative 1. Would you guys agree it's equal to negative 1 right here, no matter what? Okay? Is it equal to negative 1 right there? Right? So what I want you to do is I want you to put the range. The lowest it gets is where? Negative 1. So it's at negative 1 between 4 and 7. So that's where the range is for this graph. But then, where am I at right here? Positive 1. And then where does that go up to? Infinity. So then, what do I have to do? Now I have to say, I have to make a union with this negative 1, which is right here. And then, ooh, open circle. Does that include or not include? Not include. So I have to say soft bracket. Then I'm going from 1, and now I'm heading towards positive infinity. Now you don't have to put positive infinity, you can just put infinity. Alright? But if it's negative infinity, you definitely have to put a negative sign in front of it. Okay, it's automatically assumed to be positive. Soft bracket. So that's the domain, that's the range. I'd like you guys to do number 4 on your